Okay, today we're going to start with writing and graphing inequalities. This is IM1, Unit 2.1. An inequality is a statement that two quantities are not equal. The quantities are compared using the following signs. So when you're reading these signs, you're sometimes going to be reading left to right, but we'll talk about that later. So this first one, if I look at A and I see that the small side of the inequality symbol is next to the A, then that's going to mean A is less than B. Consequently, if the big side is by the A, then it means A is greater than B. When you add this part of the symbol here, think of it as an equal sign, and it's saying that A is less than or equal to B. When I add it to the greater than, it would be greater than or equal to B. This last symbol just means that A is not equal to B. The solution of an inequality is any value that makes the inequality true. The set of all solutions of an inequality is called its solution set. So now if you look at a graph like this, here we have an inequality x is less than 6. It's not equal to 6, so I put an open circle there. And it's less than, meaning it's all the numbers less than, meaning negative 4 2/3, negative 2 1/2. So all those numbers are part of its solution set. When I'm drawing it, remember, and I pointed this out, if it's just a plain less than or greater than symbol, you use an open circle because it means that that number is not included in your solution set. However, if you have this symbol, the equal sign, it means that the number is also included in your solution set. When your arrow goes to the left, it means that everything is less than. When your arrow goes to the right, it means everything greater than. This next part is crucial because this is what messes up a lot of people. You always read an inequality from the variable. So if I was reading this one, it would be, the first one, it would be x is greater than 9. Okay, this one is x, read it from the x, is greater than negative 4. And I should have is there, but I'm just abbreviating. This one would be read, x is less than, and I also have this symbol, or equal to 7. So for clarification, you need to understand that when it says x is less than or equal to 5, it means that it's either less than or equal to. It can be one or both. Okay, so that means that when I'm on my number line and I'm at 5, it could be here or it could be here or it could be both. So you have to understand that that line means it could be both, less than or equal to. So if I said 5 is less than or equal to 5, that is true. If I said 3 is less than or equal to 5, that is true. But when I have x is less than 4 and I do this, that is false because there is no equal sign. Okay, so when you're reading math, it's important that you understand that no more than means less than or equal to. So think about this man and he's saying, I'm going to charge you no more than $50 for that painting. Okay? As soon as you think of no more than $50, you know you're going to get that painting for less than $50 or maybe $50. Okay? On the other hand, at least means greater than or equal to. So when you ask your mom for an increase in your allowance and she says, I will pay you at least $10, you know that you might get $10, but you might get more as well. So it could be greater. Maybe you'll get 11. So I think this is just a fun way of remembering what no more than and least money helps. Okay? Okay, on this one, these are from the exploration on page 28. So let's do these together. It's saying that the temperature, so we've got a thermometer here, is at least -10 degrees. So it's at least there. But it could be more. And so we would write that like that. T is greater than or equal to -10 degrees Celsius. And I hope it's a lot warmer than that. That sounds cold. B is the elevation of Alabama. So I'm assuming that Alabama has a lot of different elevations throughout the state. But what they're saying is that the highest point, at most, the highest point of elevation is 2,407. And so we would draw that and write that like that. It's going to be less than or equal to. Okay, when you're looking at this equation, you want to be careful as soon as you see a negative sign, because you need to remember that negative signs go this way. So I have the graph here for you, and you can see that. So how you start your graph, first you look at this, and we can see that it's going to be a closed circle because it's got the equal sign on it. So I'm going to put a line here for -3/4, and I'm going to put a circle. And there it is. Okay, then I'm going to draw the line, and since it's greater than, it's going to go to the right. So there you go. So make sure that you understand that when you're on a number line, you have 0 and 1. This would be -1/2. This would be -3/4. So just the mirror image of what you would see over here. Okay, so be very, very careful. Okay, so what we're going to do here is we're going to write the inequalities shown by the graph. So the first thing I'm going to do is I need to understand that this is x. So I'm going to write an x over here, okay? And then it's not equal to, I can see an open line, and it's less than that number. And I'm going to write that number down. So that is the solution for that graph. Now, the question you need to understand is, does it matter which variable you use? Could you have used k? Could you have used m? You could have, and it doesn't matter. I would only recommend you don't use L because it looks like a 1. So don't use L. Okay? The next graph looks like this. So now we notice it's in the negative, so we have to be careful. But the one thing we do know is that because it goes this way, it's greater than or equal to. So I'm just going to use a B this time. And I'm going to say B is greater than or equal to, and it's right there for me, so -0.05. And you can see that that's what they got as well. Okay, so this is in your exploration, so pause and do these problems and then check your answers. Notice that they don't just want you to write the inequality, they want you to describe all of the values that make each inequality true. So you're going to describe what it means as well as write the inequality. Okay, so there are the two answers. If you were going to describe it, you would say that x is all of the values greater than or equal to 1. And this one would be x is all of the values greater than 1, but not including 1. Okay, for this one, you need to pause and do these 4 problems where you write each statement as an inequality. Make sure you're not solving, you're writing it as the information is given. Okay, let's look at each of the answers. 12 is greater than or equal to 5 times a number. Okay? 1/3 of a number, 1/3 of h, is less than, there's that symbol, 15. 7 is less than or equal to the difference of a number and 6. whenever you see something that says a difference of, this is the first number minus the second number. Okay, so it would be Q minus 6. And this one is the sum of a number U, and 14 is more than or greater than 6. Okay, Ray's dad told him not to turn on the air conditioner unless the temperature was at least 85 degrees. So you're going to define a variable and write an inequality for the temperature at which Ray can turn on the air conditioner. So they gave you T as the temperatures. So now you have to decide, is T is going to be greater than or less than? Well, it's at least 85. So he doesn't want it on when it's 65, so he must want it on when it's greater than 85. And I'm going to erase that silly mark there. There we go. So T is greater than. And then it says at least 85, which means it could be equal to 85. So there is my equation and the graph. A store employees can earn at least $8.25 per hour. So define a variable and write an inequality for the amount the employees may earn per hour. So maybe they're thinking about different employees can earn a different amount. So D is the dollars per hour. So maybe employee A earns $8.25. Could the employee that's been there for 6 months earn more? Sure, they could earn $10 a month. Usually you don't get that many big raises, but I can at least see that it's going to be greater than or equal to $8.25. Okay, whenever you write a fraction or a decimal with whole numbers written down here, you want to write your endpoint. Always include your endpoint on the graph. And when, just as a side note, when you're graphing for me, you only need 3 numbers. -1, 0, 1 if your graph starts here. I would always choose the middle number. So let's say it was this one. Let's say it was the 85 from the last problem. And let's say it's greater than or equal to. You can write 84 and 86. And this was exactly 85, so you could just write it like that. Okay, so you don't need to put a bunch of numbers on your inequality graphs for me. Okay, now we're going to think about the limits of real life, and you're going to wonder what that means until we do this. So a cell phone plan offers free minutes for no more than 250 minutes per month. So if you think about it, no more than is going to be this. Okay, first they're going to tell us that M is the number of minutes, and here's the graph. Why do we have this? Well, think about it. Are you allowed to speak negative minutes into the phone? I'm sure our parents would sometimes like that, but no. Negative minutes does not exist. So we stop it at 0 because that's what real life does. So that's what it meant by think about the limits of real life. And that's the end of the video. And so you can do your homework now and have a good day.